Today we're going to be looking at some relations and deciding if they are linear or nonlinear. For today, everything we're going to look at is either going to be a graph or some sort of an equation. Let's start with looking at graphs. If you are looking at graphs, in order for a graph to be linear, it has to be some sort of line. Notice that linear has the word line in it. So any graphs that are just a line of some variety are linear. Any graphs that are not a line of some variety or not one continuous straight line are not linear. So this one right here is this a line with a positive slope, if you remember that from the past. This one is linear. Whereas this curve right here, since it's not a straight line, is nonlinear. Negative slope straight line though, still okay, so linear. A horizontal line is also linear, no problem there at all. This is actually a parabola, but since it's a curve, it is nonlinear. This is what an absolute value graph looks like. We'll talk more about those later. It might trick you because this part looks like a line. This part looks like a line. When you look at the whole big picture, it's not one continuous straight line, it's actually a V shape. So even though parts of it are a line, the whole thing is not a line. So that graph right there is nonlinear. When we're dealing with equations, whether they're written with y's and x's in them, or whether they're written in function notation f of x form, in order for it to be linear, you basically can only have adding and subtracting of x and y, or x and y being multiplied by numbers. So big dead giveaways that something would be not linear is if you have variables that are being multiplied together, if you have a variable that's in the denominator dividing by a variable, or if you have exponents that are not 1. So these two right here are both linear. If you were to graph these either by hand or using Desmos, your graph would be a straight line. That's another way to think about that. So here I just have adding and subtracting, or adding things, multiplying things by numbers, that's linear. Fractions are perfectly fine. I'm just adding x and y being multiplied by fractions, that's also linear. Things like this, xy equals 7, that really means x times y equals 7. Since you have variables being multiplied together, that one's not linear. Let's look at some that are in function notation form. So f of x, remember f of x is basically like y. F of x equals 3x plus 1 would also be linear. If you were to graph that, you would get a line. Same idea here, remember fractions are not a problem, and as long as we don't divide by a variable, which we're not here. So this one right here, also linear. If you were to graph f of x equals negative 1/2 x minus 3/4, you would get a line. These bottom two are both not linear, and I'll tell you why. So for this one, we have an exponent that's bigger than 2, or that's not 1, it's an exponent of 2. Anytime you have an exponent that's not 1, automatically nonlinear. This one is nonlinear because we are dividing by a variable. Dividing something by a variable means when we graph that we're not going to get a straight line. So this one is also nonlinear. So hopefully now you're feeling super duper comfortable with the difference between a linear relation and a nonlinear relation. I hope you have a wonderful day.